Okay, in the last video, towards the end, we looked at how to evaluate the composed trigonometric inverse functions. Let's look at it more generally now. Write sine cosine inverse x and tangent cosine inverse x as algebraic expressions in x for x between -1 and 1. Here's a bonus problem. Why? Why does the question say that x has to be between -1 and 1? We're gonna, you can email me the answers to this bonus question. The setup is going to be the same. We're going to say let cosine inverse x equal theta. This makes sense because cosine inverse of x is just an angle. This means x is cosine theta. Now thinking of x as a number, I can write that as x over 1. What this means is I have a triangle, I have an angle theta, adjacent is x, and the hypotenuse is 1. This makes the opposite, by Pythagoras theorem, square root of 1 minus x squared. Now let's see, what are we asked to find? Sine of cosine inverse x, but with our new assumptions, this is just sine theta. And I can write that just by looking at the triangle. Adjacent, so it's opposite, so it's square root of 1 minus x squared. Similarly, tan of cosine inverse x in this new let's call it variable is tangent of theta, which is opposite over adjacent. So the reason we saw the general method, even though we were able to find the same answer in the calculator, previous video, is that you won't be able to use calculator in this case because we are trying to find an algebraic expression in terms of x, something that works generally. Now here's another example. Let's say that u is sine inverse x. It says write sine u and tan u in terms of x. So first of all, let's go from inverse to normal functions, regular trig function. If u is sine inverse x, this means sine u is x. So that's first task already done. Sine u is x. Now in this case, once again, sine u, the input of a sine function is angle. So this angle must be u, and the output is the ratio of opposite to hypotenuse. So the opposite must be x and hypotenuse must be 1, which gives my adjacent to be square root of 1 minus x squared. So that tan u then is opposite, which is x, over adjacent, which is square root of 1 minus x squared. So these are ways for algebraically solving for composition of inverse trig functions. Let's look at an application. It's an application to surfing. So a wave that breaks all at once cannot be surfed. You generally require it to travel before it breaks so that you can surf it while it's traveling. Now these two scientists, Robert Guza and Tony Brown, they found that for a wave to be surfable, it needs to hit the shoreline at a specific angle theta. And this theta is given by this inverse trig function, sine inverse of something, right? That's important. And that something is 1 over 2n plus 1 times tan of beta. So it's a composition of inverse and regular trig function. Now don't worry about what these things mean, they are defined. Beta is the angle at which the beach slopes down, right? So for any beach, you have this angle that it slopes down. And n takes values like 0, 1, 2, 3. Basically, it takes integer values. So what this is saying is this beta is fixed for a beach, right? Every beach has this angle at which it slopes down. And then the waves coming in, they hit the shoreline at different angles. But if they hit it perfectly at angles that are solution to this, then those waves are surfable. It says for beta equals 10 degrees, find theta when n is 3. So all I'm going to do is plug in these numbers. 1 over, when n is 3, 2 times 3 plus 1 is 7, 10, 10 degrees. I'm just going to plug this in. Sine inverse 1 divided by 7 tan 10 degrees. 1.44. That's a pretty low angle. Similarly, for beta equals 15 degrees, so if you have a beach that has a slope of 10 degrees, then a surfable wave is going to hit the shoreline at roughly 1.5 degrees. It says find theta when n is 2, 3, 4. I'll do for 2 and you can do the 3 and 4 case. When n is 2, 2 times 2 plus 1 is 5. So this is 5, 10, 15 degrees. Again, it's the same setup. So you have sine inverse 1 divide 5, 10, 15. 3.07. So what is happening here is if your angle for the beach is increasing, right, you went from 10 to 15, the angle at which the wave needs to hit for it to be surfable is also increasing. Now, interesting question here, part C. What happens in case B when n is 0 and 1? Let me do n is 0. When n is 0, I get sine inverse of 1 over tan 15 degrees. Let's look at the value of 1 over tan 15 degrees. 1 over tan 15 degrees is 3.73. Yeah, this is 3.73, which means there is no solution. Why? Because the domain for sine inverse is -1 to 1, meaning there is no angle theta for which sine of that angle would be 3.73, because it can never be more than 1. And in fact, you can check it out. If you plug this in, divide by tan 15, as expected, you would get a domain error. And so no solution. So that was for n equals 1. You can try it out for n equals 2, and you will see that once again there would be no solution. However, for 2, 3, 4, you would have solutions. We found the solution for n equals 2 here. You can work out for 3 and 4 for practice. That's going to be the end of day 1 videos. We are going to be using these inverse trig things quite a lot in the next day's video and the next material, where we use trigonometry to solve for any triangle. Okay, so that's the end of this one. Thank you.